In this next set of video tutorials, I'm going to be covering surfaces. So I'm just going to start with just a really basic introductory overview of what surfaces are and how they're defined and why we would want to use them. So what is a surface? Well, this is basically, if you want to look at it in modeling terms, it's basically like a chipboard model base. And this is where we would place our buildings and our vegetation and other objects onto. We can also visualize this as being a bare earth. So it's basically the bare earth of terrain. So if you're more familiar with working with LiDAR or with the LiDAR terms, this is basically the bare earth. So we're basically removing the pavement, the housing, the foundation. It's just the bare earth. So how is a surface defined? In planar geometry, we have 2 points. So we have one here and a second point here. And when we connect these 2 points together, we form a line. Well, that's pretty simple, very basic. And then if we have 3 points, so we have one here, second point here, and a third point down here. When we connect these 3 points together, we form a plane. Pretty simple, very basic. Using these basic concepts, the computer is able to create a triangular plane using groups of 3 points. So, as we can recall in Civil 3D, when we connect 2 points together, we call that a polyline. When we connect 3 points together to form a plane, we call that a 3D face in Civil 3D. And to create a face in Civil 3D, we just simply type in the command 3D face and press enter. The computer algorithm used to build this triangulated irregular network of these 3D faces is called Delaunay triangulation. The end product from this algorithm is called a triangulated irregular network, or for short, a tin surface. So this is an example of many little triangles that is used to form a surface. So there are some limitations to standard surfaces. Delaunay triangulation means that for any given xy point, there can only be one unique z value within the surface. Since slope is equal to rise over run, when the run is equal to 0, the result is undefined. So basically what this is saying is you have a point here, call this one of the points, and we're looking at this in elevation view. We cannot have another point sitting right on top, because then this is undefined. So this can't happen. You can't have an xy for any given xy point. It has to have a unique value. So it's either got to be way over here and then connect. So this is looking at it in section view or elevation view, not in plan view. You can't have a vertical thing going on here. So that's one of the limitations. The surface will not have a thickness. So surfaces are basically thin sheets with no vertical faces. So why would we want to use surfaces? Surfaces can model very detailed terrain at any size depending upon your computer's ability. Basically, how much system resources you have. Sometimes it takes a lot of memory, sometimes it takes a lot of processor power. Then of course you need to place the store your surface, so you need some hard drive space. And then if you're trying to manipulate it in 3D, of course it may take some video card resources as well. And then the information that you can derive from a surface is almost infinite. You can get aspect information, slope information, hydrology information, the list just goes on and on and on. And of course as landscape architects, when we're doing an analysis, we're trying to move Earth, all of this information is very, very valuable to us. So there are 3 major types of surfaces in Civil 3D. There is the standard surfaces, the volume surfaces, and corridor surfaces. And we're going to be covering all 3 of these. So the standard surface is based on a single set of points. And throughout the video tutorial series, we will be looking at points and how do we take in points and build surfaces from those points. The second type of surface is volume surfaces. And this is usually builds a surface by measuring vertical distances between two standard surfaces. And both standard and volumetric surfaces can be a grid or tin surface. And sometimes this ends up being a derivative of running some sort of surface analysis tool. And we'll definitely be looking at those as well. And then the last type of surface is corridor surfaces. And these type of surfaces are created from a corridor, such as a road or street corridor alignment. And I do have a separate tutorial series just for road and street corridor alignment. So it will not be covered in this section, but it's definitely going to be its own section since it's a very large tutorial series. So the following sections we will be exploring the following. We'll explore how to create a surface, how to manipulate and work with styles and create styles, how to basically see what we need to see from our surfaces, how to work with break lines, how to create break lines, surface boundaries, how to use surface boundaries to prevent over triangulation in kind of like concave spaces, editing surfaces, we're definitely going to learn how to edit some surfaces, paste surfaces, and working with some of the surface analysis tools.